So today we're gonna have some stuff to do. So we'll probably do 2 streams. And this is gonna be in about around 2 hours and a half. We'll do some stuff and then I'll come back later and keep going. Hopefully I'm done with the Buildspace stuff today. So structure is the method that we was talking about in the section 1. Check out my updated smart contract code. There are a lot of comments here to help you see what changed. Event new wave, address index from, uint, timestamps, and string message. A little magic Google what? Little magic Google what events are in Solidity. Oh, Google what events are in Solidity. I created a struct here named wave. A struct is basically a custom data type where we can customize what we want to hold inside it. Parse arguments passed in transaction logs. These logs are stored on blockchain and are accessible using address of the contract to the contract is present on the blockchain. An event generated is not accessible from within contracts, not even the one which have created the immediate. There are verbal waves that lets me store an array of structs. This is what lets me hold all the waves anyone ever sends to me. This is an array. Wave. Yeah, the declare struct here, and then the only thing I have to do is put the array symbol right next to it. And then specify what you want to put inside it. You will notice I changed the wave function a little as well, and now it requires a string called message. This is the message our user sends us from the prompt. Added some fanciness here. Google it and try to figure out what it is. Let me know what you learned in course chat. Meet new way. Block timestamp message. It has been first choice of us for smart contract development. Ethereum community is continuously working hard to easy and improve development with Solidity. In a recent release, emit keyword has been introduced to emit the event. To help to differentiate the functions from event, which was one of the reason of the DAO hack, which led to hard forking Ethereum and gave birth to Ethereum Classic. As per Solidity release notes, general support and recommend using emit event name to call events explicitly. In order to make an event stand out with regard to regular functions, emit event name as opposed to just event name should now be used to call events. You know about other implementations in the release here. Now, new sample code to emit an event will look like. This is about emit and block timestamp. Still feel like I don't know very well what emit is. Emits this thing to the blockchain. This keyword is used to emit an event in Solidity, which can be read by the client in that event in Solidity is to use to log the transactions happening in the blockchain. But why would you want to do that? That's the question. Can be used to call JavaScript callbacks in the user interface of that. Which listen for these events. Events are inheritable members of contracts. When they are called, they cause the arguments to be stored in the transactions log. Special data structure in the blockchain. These logs are associated with the address of the contract and will be incorporated into the blockchain and stay there as long as the block is accessible. Parameters as of Frontier and Homestead, but this might change with Serenity. Login event data is not accessible from working contracts, not even from the contract that created them. SPF proofs for logs are possible, so if an external entity supplies a contract with such a proof, it can check that the log actually exists inside the blockchain. Be aware that block headers should be supplied because the contract can only see that the last 256 block hashes. Up to 3 parameters can receive the attribute index, which will cause a respective argument to be searched for. It is possible to filter for specific values of indexed arguments in the user interface. If arrays including string and bytes are used as indexed arguments, kcat 256 hash of it is stored as topic instead. I think I sort of understand now. It's block timestamp. I think it's used to do API calls. But doesn't make sense. And it needs a new way with the message, the block timestamp, with the address, the block timestamp. Oh, it emits an event with the block timestamp. So it can be used on JavaScript to do something. And that's how it's used. Whenever we change our contract, we want to change run.js to test the new functionality we added. That's how we know it's working how we want. This is what mines look like now. Alter the script to test wave with a message from line 10 and line 13. I also call get always on line 16 and then print it out on line 17 to help me see if the waves were properly starting the way. Here's my updated run.js. Here's what I get in my terminal when I run this using npx start run. The way it looks as I described it, we can see the data and actually there was a waiver message and timestamp. It probably stores our messages, a message, and another message. So timestamps giving back to us as a type big number. Learn how to work with it later, but just know there's nothing wrong here. Looks like things work. Let's move to our content so we can see all our waves on our website. We deploy. So now that we've updated our content, we need to do a few things. We need to deploy it again. We need to update the contract address on our content. We need to update the ABI file on our content. Why do we need to do all this? So after you update the deploy, then update the contract address and update the ABI. ABI was I think it was a file to connect both languages. Yeah, something with binary interface. I think it was to it translates the code into binary, something like that. A file that does it. Contracts are immutable. They can't change their permanent. That means changing a contract requires a full redeploy. This will also reset all the variables since it be treated as a brand new contract. That means we'd lose all our wave data if we wanted to update the contracts full. Where else could we store our wave data? Where could we update our contracts full and keep our original data? One thing that comes to mind is maybe separate the contracts and make one contract communicate with the other through the blockchain. So what we need to do now is deploy again using npx start run. Change contract address in app.js to be the new contract address we got from the step above in the terminal, just like we did for the first time we deployed. Get the updated ABI file from artifacts like we did before and copy paste it into Rapid, just like we did before. If you forgot how to do this, be sure to revisit the lesson here and watch the video I made on ABI file. I'm gonna watch that again because I don't remember really well. That's an ABI. I think it's something you should do with binary. Yeah, that's enough. So here is the new code for the JS. Looping through all arrays and see, and then nicely an array that we can use the. So he does a for each, and then pushes waves clean dot pushes an object for each wave. Just start them on and then right. Where do where do we call this brand new get always function though? Once you call it, when we know for sure the user has connected wallet with an authorized account base, because we need an authorized account to call it. And you have to call this function somewhere and check if wallet is connected. Be sure to watch the live stream if you don't know what to do here. I'll be covering it there. Last thing I did was update our HTML code to render the data for us to see. Basically, I just go through all waves and create new divs for every single wave and show the data on the screen. So map.js array function no longer works. If we try to wave, it will give us an error because it's expecting a message to be sent now. We click now. For now, I can fix this by hard coding a message like live stream. I'll be showing you how you can build a simple text box to let the user write a message if you're interested. Otherwise, I will leave this to you. You want to give your users the ability to send you a custom message using text box they can type in. Or maybe you want them to send you your link to me. Or Spotify link, it's up to you. Go build a UI. Don't make this thing look how I want it to look. I won't be teaching you much of that here. So well, one thing that wasn't very clear is if they're gonna make more streams. I don't think they used to do them on the past, but they're not doing them now, I think. So I'm not really sure if it's gonna explain more about this project, this specific project later on. Well, contract set a price and send users Ethereum. Now what we want to do is send it some Ethereum to people waving at us. For example, maybe we want to make it where there's a 1% chance someone can win 5 from waving at you. Or maybe we want to make it where everyone who waves at you gets 1 cent in Ethereum for waving at you. You can even make it where you can manually send Ethereum to people whose messages you love the most. Maybe they sent you an awesome song. Easily sending Ethereum to users is a core part of a smart contract and one of the coolest parts about them. So let's do it. Start, we're just going to give everyone who waves at us this very small amount, which is 31 cents, and this is all happening on testnet, so it's fake money. Check out my updated wave function on waveportal.solve. So create a function with a string, put it into memory, which is message, underline message. Public function adds total waves to 1, also log the address with the message. I wish they explained what this percentage s is. But I guess I can look it up later if I want to. Then it pushes the waves. Pushes the wave to the waves array. Emits an event for the blockchain of the address, the message, and the block timestamp. Unit price amount. And this is the value of the price. Require price amount. Address this dot balance. Trying to withdraw more money than the contract has. And this is pretty awesome on line 7. I just initiate a price amount, Solidity actually let us use the keyword ether so we can use it easily represent monetary amounts. On line 8, we have some new keywords as well. This is required, and it basically checks to see that some condition is true. If it's not true, it will quit the function and cancel the transactions, like fancy if statement. Yeah, in this case, it's checking if price amount is equal to the is less or equal than the balance. Pretty self-explanatory. How this works is when we first apply the contract, we fund it. So far, we've never funded our contract. So it's been worth 0. That means our contract can send people Ethereum because it simply doesn't have any. We'll cover funding in the next session. I guess there needs to be a way to make this dynamic also, because I can imagine some applications require for the contract to be worth more or less money depending on what's happening. But since they are immutable, I'm not sure if that's the case. I think it will be interesting to research about Cardano data after I'm done with Free Code Camp, to understand what languages they use and what are the differences between them. Line 9 is where I send money. Boolean success equals message.sender is the address, dot call, the value equals price amount. So dot call is to send money to whatever address you put before, and with the value. As an object array as an object. Line 10 is where we know the transaction was a success. If it wasn't, it would mark the transaction as an error and say failed to withdraw money. Pretty awesome. We've now set up our codes and our codes in Ethereum. Nice. Now we need to actually make sure our contract is funded, otherwise we have no Ethereum to send. We're going to first work in run.js. Remember, run.js, like our testing grounds, where we're going to make sure our contract's core functionality works before we go and deploy it. It's really hard to debug contract code and front-end code at the same time. So we separate it out. Let's head to run.js and make some changes to make sure everything works. Okay. Line 3. Deploy value, which is the same thing we did for passing money to someone. This is where I say go and deploy my contract and fund it with 0.1 Ethereum. Okay. This will remove Ethereum from my wallet and use it to fund the contract. That's it. Line 7 plus 8, I test. Tested out to see if my contract actually has a balance of 0.1. I use a function that ithers gives me here called get balance and pass it to my contract's address. So this gets the balance of the contract. And this prints it out, the value. But then we also want to see if when we call wave, if 0. This value of Ethereum is properly removed from the contract. That's why I print the balance out again on lines 13, 14 after I call wave. I guess this message is once he sees that everything is working, he removes them. Maybe, yeah, maybe depends on the application as well. No payable constructor cannot override value. What this is saying is our contractor isn't allowed to pay people right now. This is quick fix. Need to add the keyword payable to our constructor and wait for all of this. So check it out. Now when I do, so let's put it here. This is what I get. We have been constructed. Just sent 17 from our contract, big success. And we know we succeeded because the contract balance went down by this value to the other one. Update deploy script from the contract. We need to make a small update to deploy JS. All I did was fund the contract and did it from like this line here. And also added a wait contract dot deployed to make it easy for me to know when it's deployed. Let's deploy our contract using the same old line. Now when you go to Etherscan and paste in your contract address, you see that the your contract now has a value of 0.1 Ethereum. Remember to update your front end with the new contract address and the new IDET file. Otherwise, it will break. Test out your read function and make sure it still works. And doing this will erase the previous one, the data from the previous one. So right now, our code is set to give the waiver Ethereum every single time. Our contract will run out of money pretty fast, and then the fun is over, and we need to add more funds to our contract. In this lesson, I will walk you through how to randomly pick a winner, create a cooldown mechanics to prevent people from spam leaving you in an attempt to win the prize or annoy you. Let's do the random winner first. So generating a random number in smart contracts is widely known as a difficult problem. Well, think about how a random number is generated normally. When you generate a random normally in a program, you take a bunch of different numbers from your computer as a source of randomness. Like the speed of the fans, the temperature of the CPU. I didn't know that. The number of times you've pressed third since you bought the computer, your internet speed, and tons of other numbers that are difficult for you to control. Takes all these numbers that are random and puts them together into an algorithm that generates a number that it feels this is the best attempt at a truly random number. That's interesting. I didn't know that. I saw a video from Veritasium that he explains an equation that some computers are used to make random numbers. It has to do with the population. I thought they were using those types of equations. And there are some other ones that use the atmospheric pressure and other mechanisms to make random. On the blockchain, there is nearly no source of randomness. Everything the contract sees, the public sees. Because of that, someone could game the system by just looking at the smart contract, seeing what numbers it relies on for randomness, and then the person could give it the exact numbers they need to win. So this is the same as before, I think. Generate a pseudo random number in the range 100. Difficulty plus block times 10. Let's see. Set the generator random number as the seed for the next wave. Give a 50% chance that the user wins the prize. This same code we had before, just send the prize. You just put it in the if statement before. But it didn't say that doing like this has some problems. What I understand is making it based on the block, how long it took the block to mine and block times thing. Here I take two numbers given to me by solidity, block difficulty, and block timestamp and combine them to create a random number. Block difficulty tells miners how hard the block will be to mine based on the transactions in the block. Block gets harder for a number of reasons, but mainly they get harder when there are more transactions in the block. The miners prefer easier blocks, but these pay out less. Block timestamp is just the Unix timestamp that the block is being processed. These numbers are pretty random, but technically both block and difficulty and timestamp could be controlled by a sophisticated attacker. To make this harder, I create a variable C that will essentially change based on the random number generated from the previous person who waved at us. So I combine all three of these variables to create a random number. Then I just do percentage 100 to make sure the number is brought down to a range between 0 and 100. That's it. Then I just write a simple if statement to see if the random number is less than 50. If it is, then the waiver wins the prize. So that means the waiver has a 50% chance to win since we wrote random number less than 50. You can change this to whatever you want. I just made it at 50% because it's easier to test it, just to test that way. It's important to see that an attack could technically game your system here if they really wanted to. It would just be really hard. There are other ways to generate random numbers on the blockchain, but Solidity doesn't natively give us anything reliable because it can't. All the numbers our contract can access are public and never truly random. Really, this is one of the strengths of the blockchain, but can be a bit annoying for some applications like ours here. In any case, no one's going to be attacking our tiny app, but I want you to know how it is when you're building that has millions of users. Tested it. Let's make sure it works. Here's my updated run.js. In this case, I just want to make sure the contract balance changes in the case for the person who waived. So here is the same stuff. This gets the contract, posting this variable. This waits for it to be deployed. It puts the value of 0.1. Then awaits again for the blockchain mining. This prints the address of the contract. This gets the balance, then puts the balance, prints the balance. This is the variable for the wave. And the balance of the contract again to see if it worked. If send money, it sent money. Won't always have nice tutorials like this one to guide you how to test your code. It's up to you to figure out what you want to test, how to test it. In this case, I knew I wanted to make sure the contract balance went out by this number only in the case that a random number less than 50 is generated. So run the above code, here's what I get. Also, he's printing the random number that was generated. Is this the right image? I don't see this random number generated console log here. Should be true above the balance. Yeah, I don't. There's no contract 80. So this is the address of the contract. Do you think it's this line here? Yeah, this is calling the function of the contract. Now, wave contract is equal to the money dot wave, which is the function that has the if statement. Let's keep going. I don't think I'm gonna figure out. Awesome, I have a way to randomly send Ethereum to people now. Now it might be useful to add a cooldown function to your site so people can just spam wave at you. Why? Well, maybe you just don't want them to keep on trying to win the prize over and over by waving at you. Or maybe you don't want just their messages filling up your wall of messages. Check out the code. I added comments where I added a new one. I use a special data structure called map, which is, I'm assuming, the same as JavaScript, but maybe it isn't. Mapping acts as a hash table, which consists of key types and corresponding value type pairs. They're defined like any other variable type in Solidity. Frequently used to associate unique Ethereum addresses with associated value types. For instance, in the blockchain-based puzzle game, built it was necessary for us to map a user's address to their corresponding level in the game. Okay. This is an address unit mapping, meaning you can associate an address with a number. In this case, I will be starting the address with the last time the user waved at us. You need to make sure the current timestamp is at least 15 minutes bigger than the last timestamp we start. So it makes it based on the block timestamp. True. So that's one use of block timestamp. Update the current timestamp route for the user. Okay. Yes, this is the last one. Finalize your UI, make it your own. We got all the core functionality down. Now it's time for you to really make this your own if you haven't already. Change up the CSS, the text, add some funny YouTube embeds, add your own bio, whatever. Make stuff look cool. Spend like 30 minutes on this if you want. Highly recommend it. By the way, while we're testing, you might want to change your contract's cooldown timer to like 30 seconds instead of 15 minutes like this. Just change it up. Why? Well, it can be annoying while you're testing to only be able to wait every 15 minutes. So change mine to 30 seconds. When you deploy your final contracts, you can set this to whatever you want. Setting gas limits. When you try to wait now, you may notice you sometimes get an error that looks something like out of gas. Why? Well, basically MetaMask will try to estimate how much gas a transaction will use. But sometimes it's wrong. In this case, it's made more difficult by the fact that we have some randomness involved. So if the contract sends a price, then the waiver needs to pay more gas since we're running more pool. Estimating gas is a hard problem and an easy workaround for this, so our users don't get angry when a transaction fails. It's to set a limit. On app.js, I changed the line that sends the wave through. What this does is make the user pay a set amount of gas of 300,000, and if they don't use all of it in the transaction, they will automatically be refunded. So if a transaction costs 250 gas, then after the transaction is finalized, that 50 gas left over that the user didn't use will be refunded. Events. Remember how we used that magic line below in our smart contract? I told you to Google events instantly to work. Please do that now if you didn't already. The basic level events are messages or smart contracts. Contracts throw out that we can capture on our client in real time. Let's say I'm chilling on your website and just have it open. While I'm doing this, your other friend Jeremy waits to you. Right now, the only way I'd see Jeremy's wave is if I refresh my page. Oh, so it's kind of like this the storage on normal websites, so the data doesn't disappear. Maybe it's a slightly different actually. And so automatically updates whenever there's a change. Not so it stores the data. So it's different actually. It would be cool if I could know that the contract was updated and have my UI magically updated. Even now it's kind of annoying when we ourselves submit the message and then we have to wait for it to be mined and then refresh the page to see all the updated list of messages. Check out my code here where I updated get always in app.js. Let's get always. Oh, it's the whole function. So he made a function to keep track of the events every time it's run. The contract is run. At the very bottom, you see the magic bit of code. Here I can actually listen contract throws the new wave event, like a webhook. Pretty dope, right? I can also access that data on that event like messaging from. Here those are set always when I get this event, which means the user's message will automatically be appended to my always array when we receive the event, and our UI will update. This is super powerful. It lets us create web apps that update in real time. Think about it, about if you were making something like a Uber or Twitter on the blockchain. Web apps that update in real time become mega important. I want you to hack around with this and build whatever you want. Deploying to mainnet. This isn't required since it costs real money. Do it for fun if you want to. So once you're 100% happy with your code and how your web app looks, you can deploy to mainnet, which is the main version of the Ethereum blockchain. This is something I will cover a bit on the live stream, but for the most part, if you want to do this, I really want you to figure it out. Look around in course chats for questions so far. That's wrap. You've done it. You've applied a smart contract and you've written a web app to talk shit. These are two skills that are going to change the world even more as we move towards a reality where decentralized web apps become more commonplace. Hope this was a fun introduction to Web3, and I hope you continue your journey. I'll keep you all posted on your projects in the Discord. See you all. Before I head out, go to your course chat and show us your problem. So I think I'm gonna do all the free code camp stuff first, and next time they have a project, then I'm gonna do the right way, step by step, instead of just going through the steps. Yeah, I think that's it. It's pretty cool. Maybe I'll try to do it locally instead of using Replit next time. Once I understand really well these API calls and how to make requests with JavaScript. And let's continue on the free code camp thing. See what time it is. So I was in the Redux part. Final challenges describe several methods of enforcing the key principle of state immutability in Redux. Immutable state means that you never modify state directly, instead you return a copy of state. If you took a snapshot of the state of a Redux app over time, you would see something like state 1, state 2, and so on, where each state may be similar to the last, but each is a distinct piece of data. The immutability, in fact, is what provides such features as time travel debugging that you may have heard about. Redux does not actively enforce state immutability in its restore or reducers. That responsibility falls on the programmer. Fortunately, JavaScript provides several useful tools you can use to enforce the immutability of your state. Whether it's a string, number, array, or object. Note that strings and numbers are primitive values and are immutable by nature. In other words, 3 is always 3. You cannot change the value of the number 3, an array or object, to each core thanks for the whole. You cannot change the value of the number 3, an array or object, however, is mutable. In practice, your state will probably consist of an array or object, as these are useful data structures for representing many types of information. There is a store and reducer in the code editor for managing to-do items. So this is the list. Let's see if I remember the methods and stuff. So this is the reducer for the star. To do is the data type that's going to be used here. Don't mutate state here or the test will fail. This is the case as LHT, which is the type here. So an array, our object is mutable. State probably consists of an array or object, and these are used to data structures. There's a star and reducer in the code editor for managing to-do items. Finish writing the to-do case in the reducer to append a new to-do to this state. So to-dos are the array. These uses to-do state. No, state is what should be. Reducer to append a new to-do to this state. So I need to append the new to-do. I don't know if it's a new object, a new element in the array or a new array itself. Oh, it's this thing here, maybe. No, that doesn't make sense. That's what is being used to pick this case here. To append the new to-do to this state. What to-do is that's what was confusing me. To-do doesn't have an S here, and here it has, so it's different things. So I need to append this into the to-do state. State dot append. I don't know if it's append. Maybe it works. Special action of type LHT, the reducer should add LHT items, so it's not returning. Maybe it's push. No. Dispatch. I remember there was a dispatch thing. Maybe it's that. Maybe it's on strings as well. Let me try on strings. So the state is to-dos, right? Which is this array here. Maybe. The thing is that this is an empty function. There is no. I was thinking about doing a to-do dot to-do to. Doesn't make sense, I think. to do state. There are a few ways to accomplish this with standard JavaScript or ES6. See if you can find a way to return a new array with the item from action.todo appended to the name. It's in parentheses and stuff. But the issue here is understanding what they want me to put on this array here. So I need to study more about these arguments, because I don't understand really well how they work. I understand it in this case, but not here. It's making the state of the story equal to the array, reduce, and taking the action to determine what's going to be done with the state. And action.type and should do does something, and the default returns the array. But how do I push the... What do they want me to push to the array? Redux does not actively enforce the state mutability in star or reducers. Their responsibility falls on the program. It doesn't actively enforce state mutability. Note that strings and numbers are primitive values, so they're immutable, and array and objects are mutable. There is a star and reducer in the code editor for managing to-do items. Finish writing that to-do case in the reducer to append a new to-do state to the state. There are a few ways to accomplish this with standard JavaScript or ES6. See if you can find a way to return a new array with the item from action.todo appended to them. Maybe I need to put 2 lines here. And return the state. See the hint. But aren't arrays mutable? As I was saying. Const means it cannot change through reassignment, and it cannot be declared. Since objects and arrays are mutable, treat by index, by property, object dot name, by extending variables array method. Dot push and dot splice directly modify the array. Concat doesn't modify the array, but just returns a new array. Slice doesn't modify array, but just returns a new array. So I think they want me to use the methods that don't modify the array. And it has to be the same array. But they all return a new array. And this variable cannot be changed due to the function. Cannot change through reassignment. And it cannot be declared. Reassignment would be to assign a different value. I can make it choose far. Choose far equals the choose. Let's see if this passes, but no. It doesn't feel like it's right either. If I put it on here, or maybe state frames down. I don't think it's gonna change it. Also, if I do this, maybe section. I might action access this object here. We have types and to do. Finish writing that should do case in the reducer. Reducer to append using should do state to this state. There are a few ways to accomplish this with standard JavaScript. See if you can find a way to return a new array if the item from action that also have to return a new array. We can't use push or splice because it's just gonna modify and not return a new one. Maybe spread operator. Function. Maybe I should console.log. I forgot how to use the spread operator. I should console.log. Let's see what this thing there. And it doesn't. That's the issue. How do I see if it's only gonna show me on this thing? This should help. I'm gonna go to the bathroom real quick. One of the core principles of React and Redux is that your UI should be based on your state. So one approach to designing an application is to first think of all the states needed to describe how the application works. It's also a good idea to try to describe your UI with a few values in the state as possible. There's less data you need to keep track of and update. Conceptually, there are two main aspects of this application: the actual list of current to-do items, and current filtering options. Okay, this is about the application, not the meaning of each thing. Actions are plain JavaScript objects that have a type to. Oh yes, in an object. Yeah, it's this object here. But in this case, what is this function? It's a blank function that takes an argument to do and puts the value on the object. So I think the question is actually how is a function argument stored in an object? Do this understand a little bit. It's just gonna give me the thing function actually. The thing. To do undefined. To do is not defined. Because this doesn't work, but no, because it's an argument, so I can't define it will be dependent on. Let's copy every level nesting that needs to be updated. I could the thing is I only want to pass the argument, not the type. I don't think I can do this because when you only concatenates arrays, and I'm trying to concatenate an object. I think I'm gonna see the solution because This way is already too complicated. I feel like what the solution will probably be. And the other ones doesn't go. Maybe the useful programmer is gonna have some answers. This guy, useful programmer. Already introduced. Oh, that's the problem. I guess that's why they did this exercise. So I can't return the state directly because the function that should do doesn't mutate. But the line of thinking was right about the action.to-do being the thing that I want to pass. So he created a new array that's identical to the state. I wonder if it works if we put state instead of to-dos. And then we push the action to-do the array and return the new array. Doesn't work when I put to-do. So that's right. Yeah, it works. But I didn't think that pushing the action to do would modify the const function because it's modifying the array, but the function is gonna stay the same after. In my mind, but I guess you can't do that. and they did it another way. But I think I tried to do that. To do it like that. State or concat. Return state. Action. Yeah, I was doing the spread operator. Definitely wrong. I feel like I tried to do this state.concat. That's weird. Maybe there was a typo or something like that. Oh, maybe I was doing like this instead. Yeah, I think that was the problem. Yeah, but the line of thinking was right, so let's see his explanation. Yeah, okay. One solution to help enforce state mutability in Redux is the spread operator. Spread operator has a variety of applications, one of which is well suited to the previous challenge of producing a new array from an existing array. It is relatively new, but commonly used syntax. For example, if you have an array, my array, and write new array is now a clone of my array. Both arrays still exist separately in memory. If you perform a mutation like new array.push 5, my array doesn't change. Really stuff. The spread operator effectively spreads out the values in my array into a new array. If you clone an array but add additional values in the new array, you could write the same expression but with a comma and new value. This will return a new array composed of the values in my array and the string new value as the last value. Spread syntax can be used multiple times in array composition like this, but it's important to note that it only makes a shallow copy of the array. That is to say, it only provides immutable array operations for one-dimensional arrays. Use the spread operator to return a new copy of state when a schedule is added. I have to make it equal to something, I think. Let's try with the... It doesn't work like this. I wonder if there's a way to do it with solution is much blind as well. Move an item from an array. Damage practice removing items from an array. Spread operator can be used here as well. Other use for JavaScript methods include slicing and cut. The reducer and action creator were modified to remove an item from an array based on the index of the item. So there's a state here with array in action. Here is the constant that will be used on the switch case, which is the index of the item that's supposed to be removed. Finish writing the reducer so a new state array is returned. So a new state array is returned with the item that is specific index removed. I think I have to see how this slices works again. This last method returns a shallow copy of a person of an array into a new array object selected from start to end and not included. So I can use slice 2 times and concatenate them, but I wonder if I can slice one specific object. Specific element from the is -1 the last thing is? Not quite sure. Probably a problem in the and not included. You should pick this -. The only thing that comes to mind is to slice from the beginning to the index, and then from the index into the end, and then concatenate the two. And I can make one equals one variable and one equals the other variable, and concatenate the variables. But thinking about if there's an easier way to do this. Isn't there a way to just remove the index? I think the pop method dot pop removes, but probably modifies the array. So a new state array is returned with the item in this specific index from maybe state. Okay. This is gonna concatenate two arrays and actual indexes on them. I think that's all should be done. The solution that I'm gonna do here feels like the best. If it works, don't even know if it's gonna work. It's plus one and it minus one. Should not include the action index. The I don't know if this concatenates them. I think it does, but I'm not sure. There. So the spread operator doesn't concatenate them. Or maybe I just typed it the wrong way. Yeah, it's section plus one. I think I'm gonna watch the useful programmer solution for this one as well. There are several challenges worked with arrays, but there are ways to help impart state immutability when seated an object. True. A useful tool for handling objects is the object.assign utility. Object.assign takes a target object and source objects and maps properties from the source object to the target object. Target is a target object, and which is the first argument, I think. And the source, maybe not. No, yeah, it's inherited method. And source object and maps properties from the source object to the target object. Unit matching properties are overwritten by properties in the source object. This behavior is commonly used to make shallow copies of objects by passing an empty object as the first argument, followed by the objects you want to copy. For an example, this creates a new object as a new object, which contains the properties that currently exist in object 1 and object 2. The Redux state and actions were modified to handle an object for the state. So this is the object, this is the type, fine. And we need to do something here, which is probably gonna be maybe have to do it in 2 lines. Check 1 is probably the default state, or state, because it's equal again. And then what's the object tree? Edit the code to return a new state object for actions with type online, which set the status property to the string online. Try to use object.assign to complete the challenge. So maybe it's just this. Special action type of type online should update the property status in state to online. So status is online. So the first argument I think is the one that it changes. And we go online .type action.type. And maybe I just have to do here. And this is not going to be an object, it's going to be let me see a video on this. If you didn't understand that the explanation in the video. I'm gonna go to the bathroom real quick. Well, obviously, one solution would be to make a new object and make it equal to started online, and then merge the two. And the value would be online, and then because it takes the last value, as the guys explained. But I'm wondering if there's a way to do it in online. And I don't think you can merge properties using this method, the objects. But here it's explaining using 3 arguments. I'm not pretty sure. This creates a new object that has which contains the properties that prevent existing object 1 and object 2. Object.assign takes the target object and source object maps properties from the source object to the target object. Any matching properties are overwritten by properties in the source object. Properties in the source object. This behavior is commonly used to make shallow copies of objects. So the source object overrides the other one with the common properties. Yeah, I don't know if there's a way you can do it in the way that I think is gonna work, which is with this doesn't work, I think. Well, it should be overriding because it's common. So let me do it the other way around. One. If there's other explanations. the understand. There we go. So the issue here was that I was copying this one into this one, and for some reason that doesn't work. So you need to create a blank object and merge the two. I think this, if it doesn't have a blank object, it becomes two status properties instead of merging. I wonder if I can console log this. Let's check this off and see. No, it's still the same thing, so it should work. Erase this. So why it wasn't working then? It's kind of weird. Let me comment this out to see if anything changed. Now it's offline status. So whatever is on the last one overrides the first one. But this seems to work. Let's see if this works. It doesn't. Dispatching an action type, an action of type online should with the proper status in the state online. You should not mutate state. So this, I think this mutates states. Yeah, that's the problem. So if you don't assign it to a new object, it's gonna change the properties of this object, and the exercise doesn't want that. Now I get it. Okay. So I think this is gonna be the exercise for now. I'm gonna do some stuff, and then I'll come back later probably to keep doing this. So see you.